This is a demonstration kit for inductive sensing applications. This demonstration kit here is powered by the IQS7225A, which is an integrated circuit developed by Azoteq Semiconductor, right? Unlike capacitive sensors, right, which actually these integrated circuit also have capacitive sensing capability built in it, but its main focus is inductive sensing. Now, unlike capacitive sensors, which actually require two plates, right, two electrodes, and there will be a capacitance store between the plates, then your proximity or your touch button will be recorded as you approach the button and you change the capacitance between the plate. Okay. Now, in inductive sensing, it's very similar, but this time around, you'll have coils, okay? You'll have coils that will basically generate what? An electromagnetic field. And as you approach the buttons, right, you're going to change. There will be a change in that field. You're going to basically change the makeup of that electromagnetic field. And based on how clever the chip is, it will basically detect either a button press or maybe a rotary encoder or whatever actions you are trying to register there. So right now you can see what we have here. We've got the 4 coils here, and then we've got the 4 buttons to actually interface with the 4 coils. Now, what is the main advantage of inductive sensing? One will say, well, it's because its ability to work in very harsh environment. What does it mean? It means that inductive sensors, they can work in very rough surfaces. It does not require like the surface must be so smooth for you to get a touch button register and things like that. These can work in a harsh environment. Now I'm going to demonstrate here. I'm going to take this paper here, right? And I'm going to place this paper to basically block this coil here, right? Now remember, this is a paper, it's got another dielectric makeup in it. So I'm going to just put it here, okay? Then I close the coil. And look at it. I'm still able to register the touches. So which means, despite the fact that there is a paper in it, I'm still able to affect the change in the magnetic field and get the correct button register. So this means here that I can have dust, I can have oil, I can have all sort of roughness here. I'll still be able to press and register my button. This here is not possible in capacitive sensing. This is a reason why inductive sensing are good for harsh environment applications, motor control circuit for industries, and waterproof application, underwater applications for that matter, wearable devices where someone can wear something and with all the sweats and things like that, you can still have everything's working. So this is here is just a preview. If you find it interesting, please subscribe to CMTEQ channel, and there will be information on the description box on this development kit here and the chip that is making all these things possible. On the next tutorial, we're going to look into the details of this demonstration kit and the functionality and everything that is happening here. So we're gonna go in depth and see the wonders of inductive sensing applications. Thank you for watching. Until next time, stay tuned for upcoming demonstration kit.